So first of all, I'm really glad to be here, and I have a kind of quick disclaimer. I'm on drugs right now. I have a terrible fever, and I had it for a week. So, you know, if at any point I start rambling, then take out your tomatoes and start throwing. So, you know, I know that I have to get back on the track. That would be super useful. And basically, my goal with this presentation is to set a standard for whatever presentation you'll see in your life. And, you know, so the next speaker can be completely relaxed. They cannot fuck up as much as I can. So I'll just do my best. OK, so a little bit about me. I'll try to be very short. I've been creating software since, talking about commercial production software since 1996. And right now, I'm working for a company called Tuplux. And the company is actually working for a US, one of the projects the company is undertaking is for one of the key players in the content generation market for Facebook and social services. So they serve almost 1 billion views per month and are growing. And what we are working on as a team is creating a microservice architecture consisting of a dozen or dozens of services to handle stuff such as analytics, workflow that is used to create content and stuff like that. In the previous company I worked for, we also did microservices for basically what boils down to very secure backups of medical data, which was based on microservices, which also had to be super secure and according to standards. So this is basically my current experience with microservices. And I'm so happy to be here and talk about Clojure, because for the past 2 months or so, I've been doing Ruby, which is probably a swear word, a bad word to use here. Ruby's not bad. I just found myself like reinventing things that are built into Clojure. For example, working on like 3 weeks on a pluggable architecture thing, which is very cool. I like it. I wrote it. But this is something that Clojure gives you for free with its safe way to extending types with protocols, right? So this is something that Ruby was missing. And in order to create it, a lot of code had to be written, which is basically was kind of my takeaway from Clojure and something that was imported into Ruby into the Ruby world. Okay, so the topic of this task is growing Clojure systems from functions to microservices, which is a kind of fancy title for a very simple thing. And I'll probably be talking about very boring and mundane stuff, like everyday things that you do when you write microservices. But I still wanted to find a balance between kind of advanced topics that are very specific to microservices and kind of intermediate stuff that also pertains to building Clojure systems, even if they're not microservices, and trying to kind of share my ideas about how they connect together. So there's nothing like super new or cool or interesting. So if you want to go to the other lecture, then maybe this is the time to do that. Okay, like a quick recap of what microservices are, because microservices are a pretty loosely defined concept in some circles, but actually they are not, right? I mean, if you want to talk about microservices, you need to know what you are talking about. And how many of you did some work with microservices or know about microservices? Oh, that's bad. That's bad. I cannot pretend that I know anything, and you'll probably catch me. So after I finish, there'll be time for questions and answers, and please dissect whatever I said and try to find faults, because I'm basically sharing really some starting ideas and starting points for discussion. So first of all, each service has a single business responsibility, which is kind of super important because this is not service-oriented architecture where you have a generic set of services which are kind of generic in that way that you can reuse them in multiple projects. With microservices, the approach is for business requirements, and I'll reiterate it many times throughout this talk probably. Business requirements drive the architecture. So this is like, for me, this is the key thing. And when we are talking about microservices, usually you hear bounded context, which means that you have certain areas that naturally kind of go together. And for me, the kind of litmus test is to put together things that change together. So when creating and trying to find abstractions, I'm doing kind of mental tests, like what would happen if we, for example, had to implement invoicing system in a different way, or what would happen if this application would no longer be a web application but a desktop application and stuff like that. And doing these experiments, like mental experiments, lets you actually see what happens if. Like, what happens if I change to a desktop application? Will the abstractions still hold, or are they lame? Are they very specific to the solution, not to the business requirements? So yeah, things that change together go together, and they create bounded context. At least this is the way I see. And with microservices, you prefer autonomy over coordination. Like, avoid anything central. Avoid central storage. Avoid shared data, avoid synchronization. I think avoid distributed transactions and stuff like that. Design your code in order to be autonomous. Like, you declare a contract that your microservice fulfills and stick to that contract. And I think that's the way to get the most out of microservices. So these were just a few highlights out of many things you could say about microservices. And of course, every approach comes with benefits and costs. Like, you could build a monolithic application, or you could base your application on microservice architecture. And the benefits of microservices are they force modularity. You just cannot cheat. Like, if you have separate small applications that have to interact together, they have to be modular. I mean, you could cheat by putting your business logic in a library that's shared across microservices, but this is kind of obvious cheat. When all the code is in a single code base, it's much easier to cheat. I'll talk about it later. Another benefit you get is independent deployment. So you don't deploy the next big version of the application. You can deploy a very small application as long as it remains compatible with what's already in the system. And at least in theory, it lets you use various technologies. But I think this is a weak point because this is a Clojure conference, and I mean, do you want to be able to use Ruby or Java? We could write everything in Clojure, right? But the fact is that you can use specific technology for certain tasks. For example, if you do, I don't know, analytics or machine learning, maybe you want to use C++ with OpenCV, for example, which you can use from Clojure, but it's kind of awkward, right? So you can create a small microservice that just handles that in C++. And what's more, you can probably find experts and people who are already used to writing in C++ and OpenCV. You don't have to train them in Clojure, for example. What are the costs? The costs is this is distributed, suddenly becomes distributed programming. So when you have a monolithic application, you basically call functions or methods, whatever. With distributed programming, suddenly remote calls become slow. Remote calls can fail. Like, you call a remote method and then just, the service isn't there. It can time out. Like, you don't know for how long. You call an external service, and it doesn't respond after, for example, 30 seconds. So what does it mean? Has it failed, or or hasn't it? So you have to take care to, for example, make sure that things that you do are idempotent, like you can retry them as necessary, and stuff like that starts to creep in. Another thing is consistency, which is when you are decentralizing data, which means there is no like central, for example, Postgres or even Cassandra database, but each microservice has its own data store. That in the beginning it looks bright, but as the system grows, you find yourself, for example, having to either denormalize data, like, for example, I don't know, with user email. Maybe two services need user email, and they have their own copies of this email, and when it changes, the change has to propagate throughout the network. Or you can do stuff such as like linking to data stores via kind of URI, resource identifiers, but this comes with its own disadvantages and complexities. So, and another thing is transactions. Distributed transactions are hard. They make things complex, and sometimes you need transactions. And finally, operational complexity. So you need to deploy you basically are in a constant deploy mode because you have several microservices with several teams working on them, and everything is being constantly deployed. So basically, when you start with microservice architecture, you have to deploy, at least in my view, be prepared to deploy like several times a day from day one, which adds complexity. It adds so much complexity. One reason for the complexity is that as you deploy, the microservices have to be mutually compatible, which sounds obvious, but it's not. Okay, so iterative development or waterfall. So basically, what we learned as an industry is to not create huge specifications up front, a huge design, but to kind of try to work with changing requirements. This is like, for me personally, this is a key thing. And one of the enabling things is flexibility, especially of dynamic languages. Like you capture specs, like beginning specs, code automated acceptance test, and then you can have the system evolve, you can refactor it. So it doesn't mean you don't do thinking up front, you don't think about architecture, you do, but you don't worry so much about the future because you know the software is not like a stone, it's very flexible, very pliable, and you can basically change it gradually throughout the process. Microservices change that a bit because there's a tendency to create the architecture upfront, divide the application into a set of microservices, which are separate projects, which may have separate teams. This kind of introduces the tension again. Like software is a little bit more like stone, a little less like wood or whatever. So there is definitely this tension. And there's also another thing that in order to kind of counteract that, focusing on implementation, which is the architecture of microservices, we should focus on creating business value. So as opposed to creating like huge design of how your microservices connect together up front, we should focus on really on user stories, on use cases, things that bring business value, and try to find a way to evolve microservices out of that. That's basically the key thing. And you may agree, you may disagree, but from my perspective, this is like the main takeaway from this presentation. Like instead of sitting down for a month and trying to design the perfect architecture to handle changing requirements, focus on business requirements and start building gradually. And for the reasons that I'll talk about it in a second, Clojure is perfect for that. Okay. So the idea is to build systems to make them grow. And there are several aspects of it. I wrote down 4, which is in no way an exhaustive list. First and foremost, build to understand. So this is what I'll start with in a second. But if you don't understand your systems, if the team doesn't understand the system, then especially with microservices, you're in big trouble. Because there are so many implicit ways when you have a microservice architecture, like emergent properties, which is kind of, it also appears in monolithic application, but much more so with microservices, at least in my experience. Maybe I did something wrong. You have to build to maintain. That's also kind of obvious, but the software you write, the systems you create will probably live on. You have to build to deploy. I won't focus on that. This is a huge, like, we could talk about several hours about deploying microservices. It's a huge topic. And lastly, you have to build to pivot. As requirements change and the business changes direction, you may have to rewrite some of it. You have to build in some flexibility into the system, into the development process. Okay, build to understand. So from Middle English, as you can see here, understand is kind of put things together so you can grasp them, right? It's my kind of loose definition. What it means is when you want to talk about things efficiently, you usually want to combine smaller concepts into larger concepts. For example, you wouldn't say, oh, look in the sky, there is a visible mass of condensed watery vapor floating in the atmosphere, typically high above the general level of the ground. You usually say clouds, right? But cloud is not a simple concept. It consists of several concepts, but we know what we're talking about when we say cloud. And this is exactly what's called jargon. So each industry, each area of expertise creates a jargon, which is basically a composition of smaller building blocks into larger ones. And that's probably when you want to get familiar with another domain, you start with learning about its vocabulary in order to understand what these guys are talking about at all. So you basically combine smaller concepts into larger concepts. And in order for concepts or things to compose, they must be composable. What does it mean? It means there have to be composition rules, first of all, right? So for example, if you have a dog, these words, dog, barked, the, a silly example, there are composition rules which are called grammar, which tells us how to put these things together. Like there is a definite article, and there is a noun, or the subject actually in this example, and there is a verb, right? When you have things that there are no clear composition rules for, like the stuff that you see here, then there is a kind of difficult to form a mental picture, which means it's hard to understand. And the problem with microservice approach is just that. If you have a kind of fragmented architecture with you beautifully divide it into 50 microservices, but if there is no underlying concept, no clearly defined composition rules, then you're just doomed. Because you can understand 3 or 4 or 5 services, but the system as a whole, you just won't be able to comprehend, because there are so many dynamics, so many things that come with microservices, such as, for example, schema or versioning and stuff like that, that it's just basically, I mean, that at least my idea. And in order to build really working and maintainable and so on microservice architecture, you kind of have to create the rules of engagement, like in war. You have to create a set of rules and stick to those rules, even though they limit you. Because if you go into free-for-all, just everything becomes fragmented. There are no standards. Just basically everything becomes an island on its own, and it's just you just cannot understand it as a whole. Yeah, so microservices again. I actually mentioned it, and here's a kind of again non-exhaustive list of things that are maybe called composition rules for microservices. So first is a request response. And this is something that that's the basic building block. You ask some other service for something, to do something, or for some data, and you get a response. So a lot of debate goes into whether microservices should communicate asynchronously or synchronously. It just doesn't matter, really. It's just implementation detail in a way, which can, of course, it's important. But when you want to understand the system, it's not so important. You should be able to abstract it away in your head. Request response, it doesn't say whether it's synchronous, like via, for example, post HTTP method, or is it asynchronous because you use a Kafka queue and send a request and then are waiting for the request. It doesn't matter whether you're using, for example, channels or using actor system. If you care about what happened after you send the request, then this is request response. That's kind of, at least for me, this is how I see it. Okay. Notifications. Notifications are when you send out info and basically don't care about the result. Another rule is no shared data. That's probably clear, but every now and then projects run into trouble when they want to share a database. When you share data, you cannot compose. Like, think about it, what I'm saying in terms of functions and namespaces and stuff, from Clojure. When there is a function and another function, and the first function uses like a global def and it mutates it because it's, let's say it's an atom, then you just cannot compose it with other functions because, I mean, you can do odd stuff like format your hard drive, or can send an email, or mutate the global state, and it just doesn't compose because there are dependencies that are not explicit. Isolated side effects. I wanted to talk about it a little bit more, but the time is running really fast. So you need to put your side effects in well-defined areas. Like, be very, very explicit about side effects. And compatible, which means that you have to use schema, you have to use versioning, and things that ensure that the services you constantly deploy remain compatible. Like, this is something that you cannot just wave away and run tests and see the test fail, because if we have a distributed system which may be running in production or even in staging, the tests are pretty costly and they're costly to run and they won't catch all errors. So you have to be very conscious about that. Okay, quickly, that's the key thing. Growing functions, so you go from, at least my idea for development is that you start with functions and try to capture business requirements in functions, then go beyond that, move to namespaces. Then what I have great experience with is Stewart Sierra component, which lets you divide application like in its own way into a set of kind of microservices with clear interface between them, and only then you move to applications. And basically, one of the enabling things that lets you do that is that Clojure is not object-oriented, and you're not coming from an object-oriented mindset. Like, you don't divide everything into small objects with very fine-grained methods, which are very difficult to use in a remote way, because then there's a huge overhead of remote calls. And also, in the object-oriented way, there's often a tendency to pass an object as an argument, which means that you lose control over it, and if you want to do it remotely, you need to create proxy objects and stuff like that that made RPC in the object-oriented way infamous in the late 90s. So with Clojure, you usually use functions. You have a clean way to build kind of DSLs for implementation, then another DSL on top of that, and built in layers. And you pass basic, simple data around. You're not passing any objects as a rule. There's also a tendency in the community to isolate state in atoms, not to have it around in various objects. And all of this basically makes it possible to think about data flowing through the system as data flow, as opposed to having a set of nouns that interact. So if you, I won't be able to probably talk much longer because I got 3 minutes. So look at something really old, which is data flow diagrams. They just fit perfectly, in my opinion, the microservice approach and design in Clojure in general, and think about stuff you do in terms of data transformations, really, with clear defined data stores where you put your data at rest, so to speak, and clearly defined areas which have side effects. And if you do that, the structure is kind of easy to grow beyond a single project written in Clojure with components into a set of microservices. If you approach it indifferently, then you still have monolithic application that will be very difficult to split up later. Yeah. Okay, this is just a quick example of pipes, actually. The great thing about Clojure is, at least in my experience, when you combine kind of top-down and bottom-up approach with REPL, and this lets you abstract away implementation details in a way that is separate from business logic. And here, a quick example of piping together processes, which is kind of seems simple, like one process runs, output goes to another process, and maybe like here, you want to go put it through your own function, which encrypts it, and this is not an external process, this is like a local Clojure function. And it's easy on the surface, but there are things like any of the processes can crash with an error, and then you have to bring down cleanly the remaining processes, close all pipes and stuff like that. So this is actually extracted from a real project where this kind of DSL or language extension is used throughout to simplify the code, so it's very clear what the actual business logic is, because it's not obscured by implementation details. And another quick example is Reforms. This is both actually are open sourced, which is a kind of DSL for defining forms based on Bootstrap, CSS actually, with validation and stuff like that. So the top thing is the form, which is kind of semantically defined, and the second is validation, and it just creates this kind of form, like just this simple language creates this form, which means that, again, you don't worry about the HTML, CSS, and stuff like that. You just code your form, and it's a DSL. So things like that you can extract and put into libraries that you share, because they have nothing to do with business requirements. And business requirements have to go, business requirements have to go in the top layer and probably have to do with state. And what you should get is probably this kind of layered structure when you build from on the bottom abstractions up to the top, and probably this is not so good when you get it. So this is like, I want to talk about it later, I just didn't time it properly. Here a quick example of Stuart Sierra component for anyone that's not familiar. I really recommend looking at it. That's a great way to structure your application in a way that kind of foresees a way to split up into microservices without incurring the overhead of starting from microservices from day one in the projects. Because when you split up, you get less flexibility. And the kind of component approach shares a lot of values and a lot of, I mean, it shares composition rules with microservices. Yeah, I'm actually 1 minute. Okay. Yeah, thank you.